3.1 here, graphing equations ax plus by is equal to c. What makes an equation linear? And I know we talked about solving linear equations in one variable, but now we're going to be graphing linear equations in two variables. And the reason why it's two variables because we have an x-axis, we have a y-axis. Okay? And what makes it linear is that the power to, what we would say degree, to the variable x and to the variable y is 1. And when we graph a linear equation in two variables, it's going to be a straight line. Be it horizontal, vertical, it may slant to the left, it may slant to the right, but it's going to be a straight line. It's going to connect. Okay, so the first part of this is plot each ordered pair on the Cartesian coordinate system and name the quadrant or axis in which the point is located. So just quickly, just a brief overview of the coordinate grid here. And I know it's kind of hard to see on mine because I have lines on this, but yours is a lot better. You don't have it. You have a horizontal axis, you have a vertical axis. The horizontal axis is the x-axis, so you see the x there to identify that it's the x-axis. You go left to right. Okay, to the right of 0, here's 0, even though it's not, the number is not there, written there. But to the right of 0, you have positive numbers. To the left of 0, you have negative numbers. Our vertical axis, which is our y-axis, it goes up and down. Above 0, positive numbers. Below 0, negative numbers. Okay? So, once we combine the x and y axis, it meets or it intersects at 0, 0, which is called the origin. Okay? You have an ordered pair, which I said 0, 0. Then, when we intersect the x and y axis, it's divvied into 4 quadrants. Quadrant 1, you read it, you start from the upper right hand corner, and then we have 4 quadrants. Quadrant 2, quadrant 3, and quadrant 4. So when we plot a point, okay, when we plot a point, this is the ordered pair, x comma y. Because you're going to move along the x-axis, then, not lifting your pen or pencil, move along the y-axis. So remember, our x-coordinate, you can only go left or right. Your y-coordinate, you can only go up or down. You're not going to have two separate points. Like, for example, A there, you have 3 comma negative 2. You're not going to go to 3 on the x-axis and then negative 2 on the y-axis. It's where does that point intersect? Either it's going to be in a quadrant or on an axis, but never both. You never have a point in two places. One or the other. Quadrants 1, 2, 3, or 4, or on an axis, x or y. Just as a refresher, how would you know if a point is on an axis?
Be a 0.
0, yes. One of the coordinates would be a 0. Okay? And that's how you would know that it's going to be on an x or y axis. Okay? So, it says to plot the points. We have here 3 comma negative 2, and which quadrant will that be in? 4. Okay? So this is really hard here for me anyway, because I have lines on top of lines on my paper here, and dots. So look at it. So we're saying 3, start at the origin, move over 3 spaces is positive 3, 1, 2, 3, here is 3, and then from there I'm going to go down 2 spaces because my y is negative 2, and along the y-axis the negative is going down. So we count downward, 1, 2. Here's our point. We'll label that as A. And you told me that, and I'll put the quadrants in there on the blank spaces in a few minutes. Let's look at letter B. 0, 3. where would that be? On the Y. 0, 3. Let's look at that. See, it says here that x coordinate is 0. Well, when we start at the origin, we're at 0. So we're not moving on the x. We're not going left or right because we're right there at 0. But for y, it says we're going to go to 3. So we're going to move up 3 spaces. So here's 0, and then we count 1, 2, 3. That's letter B. Letter C, -4, 1. Where is that point located? Quadrant 2. Yes, quadrant 2. Okay, we start at the origin. Our x coordinate is -4, so we count over -4 spaces. So we have 1, 2, 3, 4, and then for our y, we're going to move up 1. We have C. We'll call that point C. Letter D. The x-axis, yes. Because we're moving at x, but we're not moving for y. Okay? So, yes, we start at the origin. The x-coordinate is -1, so we go over 1 space to the left, and for y, we're not moving up or down because we're at 0. So, D. Letter E. -2 1/2, comma, -3. Quadrant 3. Now you say -2 1/2. Well, I don't necessarily have -2 1/2 there, identified, but we can approximate where it goes between which two whole numbers, or which two -2 and 4. But keep in mind, even though the number line is labeled with even integers, okay, here is -1. Here is -2, that's -3. I just want you to see that, okay? So when we start -2 1/2, we can say, move it over here for a second, we can say -2.5. So we know on the negative x-axis that this point is going to be between -2 and -3, okay? So at least moving that way. Excuse me. So here we go. Start at the origin. We're going to move over to -2.5. So it's right here in the middle. We're not really putting a point there. We're just moving to that for the x coordinate. But then we're going to go to -3. So we're going to count down 3 spaces. 1, 2, 3. So your point is not going to be on an exact, like how we had -4, 1 on the line here. Is between the two lines. And I believe you have something like that in Math Excel. I'll definitely open up those. The assignments are probably open, but you do have one like that. If we have time today, I'm going to pull up that particular assignment because I want you to be mindful of not trying to guess where those points are. There's a place where when you scroll in the grid, the ordered pairs, you'll see it. So you know exactly where to go. Okay? So this is E. And then F, 3.5, 4.5. Where would that point be? Lie. Quadrant 1, yes. So here, I'll zoom in again. I know it's kind of busy to see here. Okay, so starting at the origin, we want to move to 3.5 on the x-axis, so that's between 3 and 4. Here's 3. So we're between 3 and 4, and then we're going to go up to 4.5. So we're going to be between somewhere here is 5. It's in the middle, yes. Here, like in the center of the box. Of the grid there. Okay, in the center. Okay. All right. So yeah, in the center. So I didn't put the answers to this. So letter A was quadrant 4. B, you said, was the y-axis. C, quadrant 2. D, x-axis. E, quadrant 3. And then F was quadrant 1. Okay? Alright, so we're going to look at graphing linear equations in 2 variables by 1, making a table of values, 2, another way, slope-intercept form. Those who had me, I did talk about this. It could have been towards the end of the class, and it was probably very quick because I know the semester was ending, but we can make a table of values, intercept, and then you have slope. Okay, so if you don't know how to find the slope or anything about slope, or if you can't remember the rules for x-intercept and y-intercept, table of values is always easy to remember, because what you're going to do is create an x and xy table. Okay, and we're creating an xy table because the xy axis. Okay, so it says here, standard form of a linear equation. Just the definition. Any equation of the form ax plus by equals to c, where a, b, and c are real numbers and a and b are not both equal to 0, is called the standard form of a linear equation. Please put an asterisk or something by that, because I know at some point that we're going to be converting. You're going to be given a graph, and then it's going to ask you to write the equation. Okay, you're going to go backwards, and at some point it's going to ask you to write the equation in standard form. And this is where your x and y are on the same side. Okay? So how are we going to do this? For example, 2a, we have the equation x plus y is equal to 4. Well, we're going to create a table of values. How to graph a linear equation in 2 variables. It says locate any 2 points that satisfy the equation. Use a third point to check your work. Plot these 2 points. Draw a straight line through these 2 points. Okay? So, and I'll repeat this. 2 points is all you need to make a line. Just 2. When you have a table of values, we do a third point just to double check, but 2 points is all we need. Okay? So here's our table. Because we're creating ordered pairs. Okay? Now, you choose if you want to place numbers in the X column or the Y column. Now, we normally, and you normally see this in textbooks, putting values in for the X column. You can do it for Y as well. And or. Okay? So, I always say when you create a table, don't try to use, well, first of all, look at our grid. We only can go up to 10, negative 10, okay? So we can't go beyond what we have that's here, okay? But when you create a table, because you're making up these points, okay? Choose a positive number. Choose a negative number. But always choose 0. I'm going to tell you why. 0 is always one of those points where the point will be on the y-axis. Okay? So we can say positive 2. I can say, you want to say negative 2 and 0. These may not be the ones that you always want to use, because if we come across a fractional equation, you really don't want to have a fractional answer. Not to say that you can't graph it, but I'll give you some pointers on what happens if you have a fractional equation and you're asked to graph it. What I would say, this is what I would do to make it easy for yourselves, okay? So, what we're going to do is we're going to go in and we're going to substitute these numbers into this equation because we need to find y. Each of you, okay, I have what, 40 students in this class. Each of you can give me 3 different, with the exception of 0, but 2 different values for x, okay? That point, that line, and if you substitute correctly, that point will lie on that line once we graph it, okay? But what we're going to be doing here, substituting. Wherever we see x into this equation, we're going to substitute 2. We're going to substitute 2 into that, -2, and then 0 to find y. So we're going to have 3 separate points. Okay, 3 different points. But you want it to line up such that it's a straight line. You don't want a point here, here, and then one way over here. No, that's not what we want. Okay? So, when x is 2, take your equation, x plus y equals to 4. Where we see x, we're going to put 2 there. 2 plus y is equal to 4. And this is going back to solving equations 101. It's going to just take us 1 or 2 steps to solve it. To solve for y, we do what to this 2 here? Subtract. We have y is equal to 2. So that's the point that we're going to plot, 2, 2. Okay? When x is -2, taking the same equation, and we're going to plug in -2 in for x. -2 plus y is equal to 4. This time we're going to add 2 to both sides. We have y is equal to 6. The point that we're going to plot is -2, 6. And then when x is 0, using the same equation, I like 0. Anytime we add 0 to something, is that something, okay? 0 plus y is equal to 4, where 0 plus y is y. So our solution here is 4. And I don't have a straight edge. You can, I normally have them, but I moved my office last week, so I don't have I normally have rulers to give for you to use in class, and I don't have them because I moved. Okay, until I find my stuff. But I have them. All right, so let's plot the points. 2, 2, which is in quadrant 1. -2, 6. Quadrant 2, and then we have 0, 4. That point will always be, anytime we let x equal to 0, and this is going to lead us into the intercepts, but anytime we let x equal to 0, that's called the y-intercept. That point is going to be on the y-axis. So 0, 4 is on the y-axis. Okay? And then we connect the points. I'll make sure I keep some rulers around here for you to use. Okay. Now, we do want to, I was taught that we draw arrows at the end because this is to let you know that this line is infinite. It doesn't stop. Okay, it keeps going. We chose 3, but we have plenty other points. Okay. Any point that we can come across that touches the line is a point for that equation. And you can look at this. X, give me 2 numbers. When you add them together, that would give you 4. 1 and 3, 3 and 1. We did 2 and 2, Okay, 4 and 0. 1 and 3. 3 and 1. Okay, so we chose 3. We have plenty of those. Now, like I said, I was taught to draw arrows at the end and also extend the line out. Nowadays, I've noticed that with a lot of the programs, they draw the line to the end of the grid, and it's just understood that it's a line that's continuous. Because you do have the X and Y axis with the arrows there, so we could extend this out some more. So, I don't think I'm going to change my method, but I just want you to understand that if you see this in my math lab and you notice that the lines are not extended out but just extended to the grid, it's understood that it's continuous. Okay? All right, any questions?